So yeah, you sort of gave away a little bit of my beginning of the talk. I've been sitting here reflecting on my sins, and there are many of them. First of all, as you said, I'm a lawyer, obviously, which is probably by plenty enough to get me to hell, but also I use Docker on a regular basis and so on, and I don't describe all my computations and data and so on, so I'm probably doomed, but I'm gonna give this a stab anyway. So this is like the sketch for the program here. I'm going to give you a little bit of background about myself and how I came to do what I'm doing presently. Not because I think that I'm particularly interesting per se, but because my background is a little bit unusual, and it might be important for you to understand parts of that to take away the right things from this talk. So if I accidentally say something on the topic of computer science or anything related to it, you should just ignore it, right? But if I say something about, the interaction between programming and business and so on, it might be worth more to you. So that's why I'm sort of spending a little bit of time on that. I'm going to talk about the scenario. So what am I trying to address with this prototype that I built? I'm going to talk about a little detour that I took getting to building that prototype. About prototyping in general, what is it that you want when you're trying to prototype? At least from my perspective, it's probably the most sort of idiosyncratic part of the talk. It's very opinionated and also highly related to this particular case that I'm working on. I'm going to talk a little bit about some tooling, not a lot, but some, because I think it's actually been quite important to the process. I'm going to talk about Reframe for the third time today, but hopefully going a little bit, one step deeper than the two other speakers who were kind enough just to gloss over most bits. And I'm going to talk about friends being sort of these other stuff that makes up the prototype, and hopefully come to some kind of conclusion at the very end. So as I said, I'm a lawyer. I've worked solely as a lawyer my entire career. I've always been a sort of an individual contributor, and I've managed a lot of lawyers and dealt with the kind of tasks that lawyers are asked to do within major enterprises. I've worked within shipping and energy, green energy, I should say, shipping being container shipping mostly, and energy being wind turbines, because I'm Danish, so that's what you can do with. We don't have sun, so we do the wind. We do the wind bit instead, and pretty well, I think. I'm an amateur in the sense that I've always, until very recently, with one exception, been programming just for fun as a hobby. I bought a ZX81. Who was born when that computer existed in the room? I saw one hand. Everybody else is two, maybe 2, 3. Okay, so it's a Sinclair ZX81, very, very early sort of personal computer with 1K RAM and 1K ROM. So you can actually do stuff with that. That sounds insane, but you can. And went through all the stuff that everybody does with a Commodore and an Amiga and whatnot on the way, but always just program for fun. I did do a small stint while I was studying. I was paid for a couple of years to program in COBOL, AccuCOBOL from the Santa Cruz operation, if anybody knows if that means anything to anybody. But bizarrely, I was asked to program in this programming language, which had been mutilated by 2 graduate students from the Technical University of Denmark. They decided that object-oriented was the way to go, so they hacked the preprocessor for this COBOL environment to introduce object-oriented extensions into the language. So they took something truly awful and made it even more horrendous. So I sort of very early in doing this got an appreciation for how much of a difference a decent language can make and what it means when you are asked to use tools that are truly terrifying. So that's sort of my former career in programming. So this, what I'm doing here is very much scratching my own itch. I think I have identified an interesting business problem that could be valuable to solve throughout my career as a lawyer. I'll talk a little bit more about what it is later. And of course, I'm trying to apply some domain knowledge that I've obtained throughout my career, both from the law, and that's what I'm educated in, but also from the industries that I've been dealing with. So this is very much sort of it's equivalent of what Malcolm is doing basically with Mark, right? He's taking something from his domain of programming, build tools, and fixing that to some extent, right? So I'm trying to do the same thing with something from my sort of original background and domain. So the scenario here is based on an observation that contracts in general in business is an unmitigated disaster. I really mean that quite literally. I think it's horrifying the way most enterprises, if not all, deal with contracts. So how many of you on a regular basis interacts with the contracts that your businesses are party to, either as a supplier or a customer? Do you get asked to contribute to contracts? You get to, can you verify that this is okay and stuff like that, right? Could you just raise your hands again just to get a feeling for it? It's quite a good chunk. Is that an enjoyable experience? No. And you're not alone, I can tell you. I mean, it's not just that programmers necessarily...
But it's better than not being asked.
I think for some instances, I would agree with you. Sometimes I would actually rather hide from it, but and it's not just a programmer thing. It's not just that programmers are especially allergic to this contracting thing. If you ask finance people, operations people, customer service people, it's a universally hated thing to be asked to interact with contracts. And I've tried sort of to describe it, what I think contract creation and management is like at the moment in most enterprises, right? You're creating and maintaining these semi-structured business-critical data and logic sources under adversarial conditions. And what I mean by adversarial conditions is that there's always another party that has a direct interest in manipulating the logic of what you're trying to do in their favor and in your disfavor. Oh, so try imagining having to write programs together with colleagues who are consciously trying to implement the reverse of the business logic that you were at any point in time. And they were not shy about using subterfuge and cheating and so on in trying to do it. How many times out of 100 would you think you could create meaningful, robust programs under those conditions? And then add to that you can't actually test what you're doing. So all the logic that you're trying to build up and describe and so on, there's no way to test whether or not it works. And if you find bugs, you have to get this adversary to agree to change the bugs or fix the bugs, what you perceive to be bugs, but it's not likely that they will agree that it's a bug because it might be in their favor. And there's no compiler, there's no interpreter that can alert you if whether or not you're trying to do something insane or wrong or whatever. So it's actually no wonder that it's hard to do this, because the tooling for doing it is just absolutely horrendous. And while you can't hope to deploy all the niceties of programming, all the tooling, all the tool chains that programmers have spent decades building up, I actually think that you can adopt some of it to very good benefit in contract drafting and making the process maybe a little bit more bearable. So that's sort of the idea behind this, is to adopt some of the best practices from programming and some other stuff, and put together a tool that makes it easier, more convenient to create contracts and also execute them after you've created them. So before going into using ClojureScript to do this, me and two others did a small detour and used a tool called JetBrains MPS. Anybody here familiar with MPS? So the MPS stands for Meta Programming System, right? And it's a workbench for creating DSLs. So somebody else has realized that this thing about DSLs is a honking good thing, and that you can do it to great effect. And why did we do that? We did that because I happened to coincidentally know some people who knew a lot about DSLs and had a lot of experience creating them for other industries, insurance, automotive, and so on. And they sort of knew a lot about what goes into making a good DSL. So I took a blatant advantage of that and had those guys help me out creating a small prototype that we used to basically figure out, can we create a DSL for describing contracts that we think is it technically is it possible, and can we do this in a meaningful way? And we used the MPS to do that, and that actually took us the first step. So we validated this hypothesis that it was a good idea to create a DSL like that, using a completely different technology, but now we know that it's technically possible. So that was an important step here. I'm highlighting this because I think in many cases, the road to a prototype or a first product and so on, it has these detours, and I think it's perfectly okay. I mean, we've heard today about people leaving their entire technology stack behind, or at least trying to get out of it as part of this process of getting to a product. And I just wanted to mention this here, not because it has a sort of any direct bearing on what you're going to see later, but because it's part of the story, and I think it makes sense to do that if you have those kinds of opportunities. But convinced that we could make that work, we sort of pressed on and did the prototyping for what you're going to see a little bit later, or I did, using ClojureScript and the technology stack that I'm going to describe. So what do you want from prototyping? At least what I wanted in this case, I wanted it to be fast. I wanted a tight feedback loop. I wanted to incorporate my own feedback, my own observations quickly. I wanted to be able to incorporate customer and other stakeholder feedback quickly. I wanted to be flexible. It couldn't set up like very hard constraints on what I could decide to do. And I also made an observation very early on, due to the domain and the stakeholders in this, that just having some slides describing the idea, that would not do. I mean, the reason for that, I can speak on that for hours, but the reason in this particular case, I think, can be sort of summed up to being, there's so much skepticism of whether or not this problem can actually be solved within the stakeholder group, that you have to be able to show them something real that at least demonstrates part of the solution. So if I was just to put these things on a slide, I wouldn't be believed by most of the people I needed to convince. So that was a big part of the reasoning. And then the final one, which might be somewhat controversial, right? I want to phrase this as a question. How many of you have been involved in projects around building a prototype with this initial intention that the prototype would be scrapped completely, rewritten from scratch, and that never seemed to happen? Instead, the prototype magically morphed into a production system. All right, so I sort of, it's not because I didn't know the answer, right? But while I don't have a lot of experience doing this myself, I've been around programmers and developers long enough that I know this to be a reality. And instead of insisting on, making this illusion for myself that we would scratch then I sort of decided to embrace it. And it's actually part of one of what I hope will be clear later, one of the most important points of the talk, one of the things that I really want to stress, that by sort of embracing that this is, if I'm successful, this will be the reality. We will turn a prototype into a production system. So just accepting that is likely to happen, that has informed sort of a lot of the choices that I've made in doing this. So keep that in mind. I'll come back to that point a little bit later. So maybe we should. I want to just briefly show you what we're talking about, the prototype, so we can get a feel for what we're dealing with. And it probably, because we're basically just trying to do something that in many ways is just giving you some of the tooling that you're used to, it's not likely to impress you at all. It's likely to come across as very simplistic. I can tell you that for people who are not used to having the tools that you have on a daily basis, this is rocket science. It's pure magic to them that these things can be done. All right, so bear with me here just a moment. So this is basically what, is it readable from the back rows, or should we? Better? More? Okay. So basically what this is, I don't want to go into a lot of details, but I feel it could be interesting to you just to see a sketch of what we're dealing with. This is basically a platform for writing contracts and then executing them afterwards. The intent is that both parties to the contract have access to it. There's an editor that we'll get back to where you can edit the contract, and then you can send your draft to the other side. You can do your edits and back and forth, and at some point you agree that this is the contract that we want, and then you execute it, probably using some kind of digital signature service or something. So what's on this tab is basically just an inbox, draft contracts that are going into to me that I need to deal with. There's some drafts that I'm working on, and there's an archive of old contracts. And if you look at the data points here in the table, you can probably tell that this is shipping related. No surprise, given my background probably. This is for charter parties. Is what a lease contract for a vessel is called. So the idea here is that there's one shipping company that leases out vessels, they charter out vessels, and there's somebody interested in chartering the vessel, probably a mining operation or whomever. And they need to conclude these contracts. And I, on one side here, I'm on the, just look up here, I'm on the owner side, so I'm the owner of the vessel. And I've received these draft contracts. I'm clicking edit here, and I'm getting into an editor that looks a little bit garbled because of the size. You don't need to read it per se, but it's more important to get an impression of the rest of the UI. Very simplistically here, we have an editor component where we can edit the text. There's some blue fields highlighted here that I'll get back to, and some yellow ones too. And there's some actions that you can save. You can save the contract and so on. But more importantly is that you can actually real time do some analysis on this contract that's relevant to the users. So they can tell, commercial facts about the contract. What kind of speed consumption ratio am I operating at? It's a really important key data point for these people. It's the ratio basically between what speed the vessel can travel at and how much bunker fuel it consumes, and some other key data points we can compare to other old contracts that have recently been closed. And we can do some analysis on the document too. We can look up the vessel in databases, verify that it's been authorized and so on. I'll skip this views thingy here, but I guess the most important bit is these blue fields, which represents the structured parts of the document. So those are data points that are really important to the organization entering into the contract or negotiating the contract. And we can keep those things in a structured format while we're editing, and we can access them. So the alternative to this, just so you understand, is that these contracts are written in Word, and then they're saved as PDFs, and all this critical data about when we're supposed to deliver the vessel, when we're supposed to get it back, how much it consumes, service levels that apply to the services we provide in the respect of the vessel and so on, they end up in a PDF file. And that's not a very good way of communicating stuff to the rest of the organization, right? You would much rather have these things in a structured format so you could surface it to the right parties throughout the organization. And you could have the right parties verify as we are negotiating the contract whether or not these things, parameters, are within what we want. We can do a lot of validation. We can check that we have sane values in here. For instance, if I was to change this number here, the IMO number, that's equivalent of a license plate for a vessel. If I was to change that, we do sort of continuous validation on that to check if it's correct. Did I mess something up? No, I didn't. So here it's just looking up in a small database that this number is wrong. And finally, probably what's most familiar to everybody is, of course, we have complete history of the document, all the versions exchanged throughout the history of this negotiation, and we can tell what's been changed at any one point in time. So it's just something like this, having access to the whole history. I know you have track changes in Word, but it's a pain to use, and by the way, you can switch it off and so on. Just having a robust history of a document throughout a negotiation is like complete novelty to most business users. Having all this stuff in here in a structured format, for instance, when we are supposed to deliver the vessel, that's actually this text here determining it, and some notices that we have to give in respect of when we will deliver the vessel. It makes it possible to extract contractual relevant events from this document because it's structured form, right? So here we can tell that we are supposed to receive or send these notices at these point in times, and we can record that this has been done. Now you could ask somebody to, after the contract has been entered, to read through it and enter all these values into some kind of workflow system. But if you ask people to do that, do you think it's going to happen and do you think it's going to be correct? No, I can assure you it's not. So this is basically a way of extracting these structured elements out of the contract and using them for something business relevant, tracking the obligations that we have in the contract. And just very quickly, you can, of course, generate a complete history of all these key business data, things like the consumption and what you're being paid, throughout the history of, and you can do a dashboard and say across all the things that we're negotiating here, how are we doing commercially? This doesn't look very good, this looks good, maybe this has taken a little bit of time to conclude here. You're tracking how many drafts have we done in our attempt to close the contract, and so on and so forth. I won't bore you with more of that. It's just to say that it's basically just, instead of using a word processor to write your contracts, you're using a more intelligent platform to do it, and you can exchange these drafts back and forth and have access to all this information that's critical to your organization. So does that make sense? Is it fairly transparent why this might be a good idea? Yeah. Okay, good. So we'll flip back to the presentation. So in doing all of this, the tooling that I've used is mostly these things. How many people are familiar with this kind of tool chain? Have everybody sort of seen how Figwheel works and live reloading and stuff? We don't need to do that. Is it interesting to somebody? I'm happy to do it. I can do it very quickly. Just hang on just a second. So, for instance, if we were to pull up Emacs here and say, okay, so if we edit this, this file that you're looking at over here, it's a representation of the view that you're looking at on the left side. And if I kill this line here and save the file, automatically the view updates. And this is really nice for building these things and experimenting with them as a developer when you're doing it. But I've actually also used it when speaking to potential customers, and just to show them how flexible this is, not and edited stuff on the fly. So if they asked, a question like, okay, so I'm looking at this data over here, but that's really not how I want to see it. Maybe I want something else. Maybe I want the 5 last contracts instead of the last 3. I mean, and just to show a potential customer that you can go into one file, delete something, add something, and the UI magically changes. It's a bit of a cheat, right? Because everybody knows that you shouldn't be, that's not how you develop it. There's more to it than that. You probably want to write some tests and whatnot too. But it's really something that, if they're used to interacting with IBM as a supplier and being told that it will take a couple of months to get this new release into production, and somebody shows up with a laptop and is able to edit stuff on the fly and do these things, it actually makes a difference. So that's my experience based on this. So prototyping and the ability to be fast and dynamic and so on, it's not just about what your own experience is. How am I doing for time, Vijay? So reframe, we've talked about it a few times, so I'll try to be quick, but still, I've adopted Reframe as a way of structuring this application, and I agree it's sort of a pattern, but it's a very opinionated pattern, and it puts some restrictions on what you should do, and it punishes you if you don't follow those rules quite severely, actually. So it's kind of a masochistic thing, but it turns out in the end that it's to me at least, it's a good thing. So what it does is, I like to think about Reframe as reagent. Is everybody familiar with reagent? So it's React.js in a ClojureScript wrapper, basically. I like to think about it as a reagent, some structure, and a flow. And you've seen this flow graph before, and I'm going to try to speak a little bit more in depth about that. If there's something you want to ask about it afterwards, I'm unfortunately going to be leaving quite quickly, but I'll be around for like 10 minutes after the talk. Other than that, hit me up on Twitter or on the Slack channel. There's a magnificent Reframe Slack channel under the Clojurians Slack channel where people are super helpful. So the idea behind the Reframe is that it works in a continuous loop. It starts out, in this case, you could start any point, but in this case, we're starting with an event. And an event is basically a call to a function inside a view. I mean, what you just saw here this is a view file that we looked at here that represented this particular tab. So basically, the only thing that you are allowed to do in Reframe in these views, you're not supposed to put any logic into that file whatsoever. You're only supposed to dispatch events from the view. So you dispatch an event, it's named by a keyword, and you can give it a payload of some sort that you want to send with the event. And then the event is picked up by some event handlers that you write in a separate file. And these event handlers, they figure out, so this thing happened, what am I supposed to do? And they can do tons of different things, but they need to do it in a fairly restrictive way. So if we want to do something that has an effect or co-effect, I should say, on the world, we want to do that in a fairly controlled way by describing the desired effect in data and handing it off to a so-called effect handler that deals with these effects in the outside world. So you keep these event handlers as pure functions, and you describe the sort of effect that you want in data. For instance, an HTTP call, a call to a database or whatever, to local store, and then you hand it off to reframe, and reframe makes sure to produce those effects that you want. At the same time, you update the state of your app. So in reframe, the whole state of the app is contained within this specialized atom, and you change the state of the app here. It's the only place in the whole chain that you're supposed to change the state. So now you have a new state. At the same time, in these views that you saw, those views, they depend on subscriptions to the states. So they have a specific sort of view of the state for the data that they depend on. That could be like the contracts in this system. And those subscriptions, you write specific in a separate file. You write out your subscriptions, and in the view, you can then rely on those subscriptions or call them and get that data that they represent. And then, if there's a change, the whole thing is handed off to Reagent and React, and a new view is generated if this query somehow changes. So I hope that makes sense. I want to stress what the advice that's been given a couple of times today is read the README for this project. It's been notorious in the past for being quite hard to get. It's been rewritten recently, and now I think it's an excellent piece of documentation, and it actually really shows you how to use reframe. The other thing that I would add is, please do read through the to-do MVC example for reframe, because there's a ton of extra stuff in that example that shows you actually how to use reframe in practice. So the README is not super sort of, it's more theoretical really about how reframe works in many respects and so on, but you get a lot of the practical stuff from the to-do MVC application. It shows you how to deal with a lot of the stuff that you will run into. So, friends and picking friends. Picking friends is really important, and picking good friends is even more important. So one thing I want to stress here is that while building a prototype, you're moving quickly and moving fast and so on. If you accept this premise that you will turn it into a production system at some point, picking the right other components is really important, and picking something that's not going to trip you up later is really important. So I spent quite a lot of time and took a lot of advice, primarily the latter, on what components to use to build this thing up. And I ended up relying on quite a few things, but these are the primary items. Are these things, are they sort of generally known to people? No, okay, so we'll go through them. So ProseMirror, everybody knows CodeMirror, right? You've seen it already today. It's like this code editing component that you can use. This is actually the prose version of that. The author of CodeMirror sort of came to the conclusion that a lot of the stuff that you could do with a code editor might be actually very useful in having rich editor components for the web just for text. So this is the prose version of CodeMirror, you can say, where he's not made some of the mistakes that he made in implementing CodeMirror. This is by his own admissions. It's not my analysis at all. And it's a super strong piece of software. I mean, it doesn't do any of the nasty things that you would see in other JavaScript libraries. It uses persistent data structures, which we know and love from Clojure, not ClojureScript persistent data structures, but its own version of them. But it means that interacting with it from ClojureScript is really pleasant, which gives you super easy change tracking and collaborative editing and so on, just with this one component. It's robustly extensible. It's been put a ton of thought into how you can extend this thing. And thirdly, it has excellent documentation. And just one more example maybe is, actually you can only change the document using transactions that you apply to this immutable data structure that represents the contents of the editor at any one point in time. So you can tell that it follows directly sort of in the path of a lot of the ClojureScript and Clojure philosophy, which has made it not a pain to use at all when interacting with it from ClojureScript. If you're using a different component that just handed you back sort of mutated state without all over the place, it would be a completely different story. CouchDB is a document-based database. It's actually a pretty old piece of technology. It's built in Erlang. It uses MapReduce for its queries, so it's highly performant for that if you want to do it. But it also supports MongoDB-style queries without the arbitrary data loss that you can get with Mongo, right? So it's actually, I mean, if anybody's used Mongo, it's actually quite a pleasant way of querying a document database. That part is good. I just don't like the arbitrary data loss when it comes to contracts and so on. It feels, it doesn't feel like a good fit. So, but what it also does is it has an extremely strong replication mechanism, which becomes important in just a moment, and it has change feeds just built into it. Something that's just arrived fairly recently, I think, in Postgres. But that's been there for forever in CouchDB. Really strong piece of tech. It's supported by both IBM and Cloudant, and in production use for some mission critical systems around the world. CouchDB. This is actually, I think, one of the game changers for me in building this, and why I sort of feel I've been able to do a ton of stuff with very little code, besides just using ClojureScript in general. So this is basically an in-browser version of CouchDB. So the whole API of CouchDB, the server-side database, runs inside the browser. And you can interact with it just as you would with a CouchDB database inside the browser. And it's able to replicate and generate change or replicate to and from CouchDB. So the whole mechanism in this prototype, that when I, for instance, go here and choose to edit this document, delete something arbitrary here, and send it to the other side. Just have to log in here. So now that document, you take my word for it, this top one here is the same contract that you just saw me edit and send to the other party. All that stuff is handled purely using the replication mechanism of CouchDB and this CouchDB in-browser database. There's no other backend in this system besides the CouchDB database that handles all the communications between the different users inside the system. So getting that basically for free when you're building a prototype is just huge, right? It's a complete game changer. All the stuff that you don't have to do, and it's robust enough that you can turn it into production code. It's used for production code for similar scenarios in the real world too. Also, this thing has excellent documentation. It has good reference documentation. It has got very strong use case documentation. Also very important, I think, in picking that. So, my conclusion on this is that this balance between hammock time and speed is really, you're familiar with the concept of hammock time that Rich Hickey uses. I mean, think about stuff before you just go implement it. Even though I felt an enormous pressure to move at speed here, every hour that I spent just reflecting on this and taking advice from cool people has been worth it. And thinking about, is ProseMirror the right thing? Is CouchDB the right thing? Is PouchDB the right thing? And so on. Is Reframe the right thing? And the time spent researching it and reflecting on that, it's all been more than worth it. At the same time, I have a technology stack and some tooling that lets me move extremely quickly when I come to a conclusion. And I think that balance is key. The other observation I would say that today with client-side ClojureScript and stuff like CouchDB and PouchDB, you can get incredibly far just on the client side without ever having to worry about a huge backend that you need to build up when you're in this prototype phase. And somebody else actually mentioned this constraints thing, right? I embrace the constraints that Reframe puts on you, how to do things, the constraints inherent in ClojureScript using immutable data structures and so on. Just embrace it and go with it. The fact that I've used Reframe means that it's abundantly clear where I've cut corners and where I need to fix stuff when I need to turn this in, or as I'm now in the process of turning it into a production system. It's so clear because the conventions are so clear and the rules are so clear. So when I've done something messy, it just stands out at you. You don't have to look for it. It's not hidden where the compromises are at all. That's really important. Know your tools. I think just I'm by no means an expert at using this technology stack. If you want to talk to the expert, he's sitting down here. Arjen knows, I think, this tool chain better than most people. So hit him up if you want to know how to get the Cider and Figwheel and refactoring tools and stuff to work. He's very good at that. Or watch some of his videos online. And lastly, I think leveraging the right JavaScript libraries, thinking about, is this a fit, or are you going to be working against the grain when interacting with this JavaScript library, or is it going to work nicely when working from ClojureScript? And the same applies basically to CouchDB. There are some tools that are just so alien in the way that they approach things that they might be very cool, but it's going to be a pain interacting with them from a platform like ClojureScript. So think about that. I hope that made sense. That's all I had. Are we sort of pretty close to time?
Okay. That was a fantastic talk, Martin. Thank you. I don't think as a programmer I'd never look at the lawyers the same way again. So questions. We have, I think, almost 3 minutes for questions. So if you have anyone, yeah.
Thanks for the talk. I just don't exactly understand how this backend works. So you mean that kind of a lot of the business logic is in the database directly, in the CouchDB?
So the thing is that this use case, the sort of back-end business logic is very minimal. It's mostly about transporting stuff between the different parties to like a contract, right? So it's mostly doing that. So there's not code as such running inside CouchDB, although you can actually do that, and it's encouraged as opposed to stored procedures in SQL databases. CouchDB is made to actually more actively run code and validate stuff when you're running it. But right now it's only relying heavily on the replication mechanism and the change feeds. So its ability to move data between the different CouchDB instances that are running in the browser via a backend, and then advising the different end-user agents that something has changed and they should update something accordingly. And that just happens to be, for this use case, the primary sort of back-end business logic. A ton of the other stuff is going on actually inside the browser and is handled by Reframe and ClojureScript.
And the other thing, can you still charge the same amount of money if you show that it's so easy to change?
I would say, so key to charging the right amounts and extracting a reasonable value from your users is knowing their costs, right? Mm-hmm. And the impact of them not having something like this. So I wouldn't even dignify, any comments related to this with anything. I would just say, I know how much you're saving, so I know what the price needs to be.
Okay, thanks.
And if I'm right, then I'm going to be making a sale. If I'm not, I'm not.
Any other questions?